Hello, this is Mrs. Ross, and this is 5.3.2 Motion in a Vertical Circle Quiz Review. Okay, so on this first one it says, a bowling ball weighing 71.2 newtons is swinging like a pendulum at the end of a 3.8 meter rope. As the ball swings through its lowest point, its speed is measured at 4.2 meters per second. What is the magnitude and direction of the acceleration of the ball at this point? So I drew a free body diagram. And this is kind of like this. This is supposed to be a pendulum. This is 3.8 meters. This has a weight of 71.2 newtons. Acceleration is inward. Velocity is equal to 4.2 meters per second. So acceleration is equal to v squared over r. So I plug in 4.2 squared over 3.8, and I get 4.64 meters per second squared. And acceleration is towards the center, so this is my answer. Okay, next one. A ball weighing 60 newtons is swinging like a pendulum at the end of a 6 meter rope. At its lowest point, its speed is measured this. What is the tension in the rope? So I drew another picture. So this is 6 meters. This is 60 newtons. The velocity is equal to 5.0 meters per second. And if I were to draw a free body diagram of this thing, I would have the force tension and force of weight, which is equal to 60 newtons. So I found the acceleration. Velocity is 5 meters per second over the 6, so acceleration is 4.16 meters per second squared. And then I said, okay, let me find the mass. If this is 60, this is mass times gravity is 60. So I have mass times 9.8. Let me put a little there. Okay. Is equal to 60, so my mass is equal to 6.12 kilograms. We'll do that here. So let me go ahead and do the sum of the forces in the y. Are not equal to 0, but are equal to mass times acceleration. So I have force of tension minus 60 is equal to ma. So I'm going to add tension to both sides, or add 60 to both sides, so I can solve for my tension. That goes away. Equals ma plus 60. So this is equal to 6.12, which I found over here, times my acceleration, which I found up here, plus 60. And this is equal to 85.5 newtons, which is B. Okay. A 50 kilogram stunt pilot pulls out of a vertical dive, changing her course to a circle in a vertical plane. If the plane's speed at the lowest point of the circle is 95 meters per second, what should the minimum radius of the circle be for the centripetal acceleration at this point not to exceed 4 times gravity? Okay, so let's see. We have our mass is equal to 50 kilograms. We have our velocity is equal to 95 meters per second. My acceleration is 4 times gravity, which is 4 times 9.8. 2 meters per second squared. I'm looking for radius. Okay, so I know that acceleration also equals v squared over r. So that would be 39.2 squared over r. Oh, no, I did something wrong. Nope, that's not right. Hold on, let me erase that. What was I thinking? Okay. Let me go back. I'll use a different color. Okay. Actually, I was right. Okay, I'm so sorry. So acceleration is equal to v squared over r. I'm going to plug this in here. I'm going to plug my velocity in here. So I have 39.2 is equal to 95 squared over r, and I'm solving for r. So r is equal to 95 squared over 39.2, which is equal to 230.22 meters, which is this one. Okay. A small child's leg, when she walks, can be modeled as uniform circular motion. Assume each hip moves in a circular arc to the length of the leg, with the weight-bearing foot at the center of the circle and the child's entire mass concentrated near the hip. Calculate the maximum speed at which she can walk if her weight is 20 kilograms and the length of her leg is this. So I have a mass of 20 kilograms. I have a radius of 30 centimeters, which I need to convert to meters. And I'm looking for V max. Now the formula for this is on formula for V max is on page 18 of 30. And it's V max is the square root of G times R. It derives it for you, but you really just need the formula here. So you have 9.8 times 0.3 meters. And then you take the square root of that and you get 1.71 meters per second, which is B. Okay. A man is walking, swinging his arms through a 45-degree angle every 0.5 seconds. His arms are 70 centimeters long. Assuming the arms... Okay, so I used... move with constant speed during the swing. What is the acceleration of 1 gram droplet? Okay, so I used the guided practice on page 22 of 30. And we're looking for acceleration. Okay, so I have t is equal to 0.5 seconds. I have mass is equal to 1 gram, which I have to convert to kilograms. To get my radius, I have to figure out what part of the circle 45 degrees is, and this is 1/8. So my distance that I'm going through is going to be 1/8 of the circumference of the circle. My R here is 70 centimeters, which is 0.70 meters. So let's go ahead and find our velocity, which is distance over time. So I'm going to plug in my distance from over here. So I have 1/8 times 2 times 3.14 times 0.7 over time, which is 0.5 seconds. And I get 1.099 meters per second. And then to find acceleration, I plug this in for my velocity, and I'm going to plug this in for my radius, and I get 1.725 meters per second squared, which is A. Okay, a 0.9 kilogram ball attached to a cord whirled in a vertical circle of that. Find the minimum speed at the top of the circle so that the cord remains taut. So I have mass is equal to 0.9 kilograms. I have a radius is equal to 2.5 meters. And I'm looking for the minimum speed. Okay, so I kind of drew a picture of this. I have and this ball is going in a circle and I'm at the top of it. So I have mass times acceleration, force of weight, force of the tension of the line. So if I sum my forces in the y equal to mass times acceleration, I get force of weight plus force of tension is equal to mass times acceleration. I'm going to, this is, oh, I see what I did. So this is mg plus ft is equal to, and I'm going to plug in v squared over r here, since acceleration is equal to v squared over r when we're dealing with circular motion. Okay, so the velocity is least when ft is equal to 0. So that means I have mg plus ft is equal to mv squared over r. This is going to go away. I have mg equals mv squared over r. My m's are going to go away. I'm solving for v. So I end up getting the same formula as the v max. So I get g times r, which is equal to 9.8 times 2.5, which is 4.94 meters per second. That's B. Okay, I think I can do one more and then I'm going to need to do part 2 video. Okay, for a stunt plane traveling at a speed of 320 kilometers per hour, which we're going to have to convert to meters per second. What is the minimum radius of the downward arc the pilot can fly without blood being forced into the top of his head? The centripetal acceleration at which blood is forced to the top of the head is 2.5 times gravity. So if acceleration is equal to 2.5 times gravity, we have 2.5 times 9.8, 24.5 meters per second squared. And then let me convert this to meters per second. That's meters, and then 1 hour, 60 minutes, 1 minute, 60 seconds. So all of these units cancel. I get meters per second, which is what I want. When you multiply and divide all of that out, you get this. Okay. So I did A is equal to V squared over R. But I needed to find A, so let's see. I did acceleration minus gravity has to be less than 2.5 of the gravity. I think I'm going to have to do this one in my next video. So I'm going to go ahead and stop and I'll start this one over in the next video.